chance to overload your brain instead this afternoon. As you can see here, we have some cameras set up as well for our live stream on YouTube. So welcome to this Poultry Worlds seminar on health and nutrition, both in person and virtual. My name is Fabian Brokketer, and as the editor-in-chief of Poultry Worlds, I will guide you through today's program. This seminar will focus on the veterinary feed and management aspects of ensuring our birds' well-being from hatch all the way until slaughter. We have organized a lineup of 4 speakers for you today, which are on the screen now, and each of them will share their expertise on gut health and antibiotic reduction. When it comes to nutrition, I often compare broilers to kids. When I ask my boys what they want to eat, chances are that I will end up at a fast food chain and not for their good salad they serve. Calories instead of nutrients, that's what my oldest son says. That's the name of the game. And you understand, they don't get to choose their menu often. But what are we feeding our broilers? Especially in times where feed ingredients are really expensive and becoming more and more expensive, and the best quality is not always available. As you all know, there's a fine balance between feeding for optimal performance and overfeeding on the one hand, or even misfeeding altogether. The risks for disrupting gut balance are huge, and when that happens, you open a can of worms. And I'm not meaning the protein source, worms, there. With bacteria roaming free, intestinal diseases are never far away. Knowing that repairing issues with antibiotics is not a preferred route to go to anymore, understanding the gut and the gut dynamics is key. And that, ladies and gentlemen, brings me to the first speaker of today. It's my honor to introduce Maarten de Gussem to you. Maarten is a poultry veterinarian. Hello, Maarten. Good to have you here. He is a global poultry consultant at VetWorks, and besides that, he functions as an academic advisor at the Faculty of Veterinary Medicine at the University of Ghent as well. In his presentation of today, Maarten will share a vet's perspective on gut health and antibiotic reduction, which is the main topic of today, of course. So good to have you here.
All right.
And here is the clicker, and the audience is yours.
Great, thank you, Fabian. Thanks for the invitation again. It's also a pleasure for me to be here, also in live. A lot of familiar faces, some new faces also. So it's really an honor to be able to speak to you today. Now, this afternoon, you will see we have a lineup. I checked the lineup. We have 4 speakers, and I'm quite fortunate because without seeing their presentations, I think my presentation will be a very good introduction for what they will talk about, okay? So that also means I will leave some space for my presentation for them because they will fill in some topics that they are specialized in. But you will see that in the end, the whole story on gut health and the link of gut health with antibiotic reduction, it's a very complex subject, but the more we are understanding the interaction between the different parts of that complexity, it becomes a very logic story. So I would like you to leave the room today with the idea that yes, there is a very high level of complexity in the subject, but we start to see a logic sense in that story. And when we just take one step back, before we zoom in into gut health, it's important to know what are the drivers that we have today in the poultry industry. You will have seen other meetings this week here at VIV in Utrecht, people talking about welfare, sustainability, economics, the marketing behind the poultry industry. One of these drivers is for sure antimicrobial usage. We are in Europe here. In Europe, you would say, that's not news, right? That has been a topic for the last 20 years. What is very remarkable is that we start to see that this topic of antimicrobial usage is accelerating in terms of importance also in other regions in the world. If you look at the US, we have some types of production that went a lot further than the European producers in reducing their antibiotic usage, even banning products such as ionophores. If you look to Asia, where we always thought they will be the last ones to, let's say, look less pragmatic on the topic, we see that in some countries, we see dramatic changes in the way they look at use of antibiotics, looking for alternatives. And it goes sometimes, it's not a legal requirement, sometimes it's a market demand, and sometimes go extremely quick. We always thought that Europe was like heading up, but now we see that some countries are even bypassing that demand of understanding how to reduce antibiotics. When we look at this consumer demands, of which antimicrobial usage is one of the drivers, we need to match these different requirements like welfare, sustainability, antimicrobial usage, and economics. You will see that from a certain perspective, these are conflicting interests. I'll give you an example. If we would focus only on welfare, it might be that we lose sustainability, because welfare measures very often might lead to more use of protein and energy for welfare expression rather than for growth, okay? So it could be conflict. Now, we see there is a poor correlation between these different drivers, but the trick is for us is to understand how we can connect those different drivers within gut health, and you will see it in all of these topics that I mentioned, gut health is playing an extremely important role. If you don't control gut health, you can't match these different requirements that you will have. Gut health, I'm a veterinarian, there's nutritionists, there's production managers. This is the beauty about it. For gut health, everyone now understands that you cannot solve it from a veterinary point of view or nutritional point of view or production point of view. You have to work together with these different people. And the aim that we have is we want to reduce antibiotics, but nobody wants to lose performance, right? 15 years ago, we said it's not possible to reduce antimicrobials without losing performance. Today, that's not true anymore. We know that compared with 15 years ago, by understanding the whole complex better, we know that we can do a better job than just using antibiotics in terms of keeping a good gut health and a good performance. Now, if you want to look at antimicrobial usage, I also want to show you it's not only gut health. So there's also, in some regions, especially when you have endemic issues like AI and NCD, we can try whatever we want with gut health to reduce antibiotics, but there the primary goal of using antibiotics is still to prevent mortality. I just want people to remember that, that if the bird is in need of antibiotics because you live in a respiratory challenge situation, they should have access to the antibiotics. In this presentation, we are therefore mainly looking at where we can reduce antibiotics in, let's say, non-endemic regions, non-endemic for NCD, AI, and MG, where gut health is taking about 70% of that use of antimicrobials. So when we look at performance and the link with antimicrobial usage, there's 3 reasons today why we use antibiotics. The first one, by far, globally, is gut health and zoonosis. I added zoonosis here because one of the speakers will also zoom in a bit on the link of alternatives of antibiotics in control of salmonellosis. So gut health and zoonosis are very much linked to each other because salmonella and Campylobacter are residing in that gut. A good gut integrity is really important also to be able to manage zoonotic issues. Respiratory health comes on the second place, and the runner-up is locomotory health. We will not focus on locomotory health, but also there we see there's a strong link with gut health, all right? So whatever I say here, it's like an average picture. It's not relevant for you in your farm. Your farm situation could be very different from the average, all right? So you always have to judge your own situation in your own farm. So this is what I showed before. The drivers for change are these different subjects, and all of them, there is a link with gut health. When you look at the main function of the gut, and today I will not go very much in detail about the background, the mode of action of gut health diseases. I want to just give the introduction for the next speakers, but remember the main functions that we have of the gut is, of course, in the first place, digestion, absorption of nutrients. You all know that, but remember that we are focusing to reach that we see also the gut as the interface between the organism, the host, the chicken in this case, and the outer world, which is the immune system. So we focus a lot on the immune system in order to be able to maintain that balanced gut health and to maintain that performance. This is a slide that I've used many times before to show you what goes on in the real world. In every farm, people think I have a caged broiler facility, I don't have coccidiosis, forget it. People think I have slats, I have no coccidiosis, forget it. I've been scoring chickens in all these kind of systems. There's coccidiosis in every broiler facility in the world. And what happens in all the broilers in the world, in all the broiler houses, there's no exceptions, is the following. We will have, at the first stage, around 14 days of age, a normal gut with well-developed villi. The coccidiosis, which is the most important predisposing factor for bacterial and necrotic enteritis, will start to put damage. It's a parasite that is inevitable to be present in your farms. You cannot avoid it. And what happens is that this parasite will start to cause damage to the gut. What then happens is a natural chain of reactions where you have a combination of a damaged gut that is reacting with villus fusion to limit the surface that can be attacked by the parasite. We start to see more mucus production to recover the integrity of the gut. And of course, we have the immune system that says, hey, we are under attack, we need to protect ourselves, so let's raise the immune capacity of that gut. By doing that, we start to see a number of secondary effects that actually enhance the main problem that we see today in broiler production, which is bacterial enteritis, necrotic enteritis. What happens is that the immune reaction is starting to cause the tight junction to become loose. We have plasma proteins leaking into the gut, and the dysbiosis, and now comes, so we have the inflammation is in relation with a dysbiosis. So we have a disturbing of the microbiota, okay? And that is, of course, linked with the fact that we have abundant amount of feed ingredients in that gut because we have poor digestion and absorption. So all that together, the plasma proteins and the bird that keeps eating, because we don't see this in layers. Why we don't see this in layers? Because the layer, it acts like a human. When we have something going on in our guts, what happens? You stop eating. Your brain is being told you're not hungry anymore. You can't digest it. But this broiler is being selected to never stop eating. And that is why this abundant presence of nutrients together with the plasma proteins is causing this dysbiosis to happen, okay? So it's complex, I told you it's complex, but if you follow this sequence of events, I think you see it in front of you what is going on in that gut. And now we have to find solutions how to solve that. I mentioned coccidiosis is the main predisposing factor, but for me you can replace it with mycotoxins, with viruses. You will have a very similar chain of events, but the most common one is coccidiosis. That is also why whenever we talk about gut health programs, the anti-coccidial programs is such an important one. So what we see is that vicious circle of bacterial enteritis. We have that high feed intake broiler. We have these nutritional factors. We have cocci, mycotoxins, viruses. let's call that we have an oversupply of nutrients in that lumen. That leads to a dysbiosis. That leads, together with the damage, to morphological functional alterations in the gut. That means that we have a system in the gut that has less ability to digest and absorb nutrients, so we have a poor digestion of feed and absorption of nutrients. That is per definition, in combination with that high feed intake broiler, is an oversupply of nutrients, right? Now, why do we call this pathogenesis a vicious circle? Because what we noticed is that historically, when we were trying to break the circle by using antibiotics, focusing on the second step of the circle, by focusing on controlling the bacteria, what we notice is that as long as we use in-feed antimicrobials from day one until finish, everything is okay. But the moment we start to switch to drinking water antibiotics, which we don't give from day one until the finish, no, we give them for 3 or 4 days, the moment we start doing that, what we noticed is that the moment we use antibiotics, we see an improvement. The moment we take them out, the problem is back. Actually, it was never gone. So a vicious circle means that you can only break it when you actually have a solution for each of the first steps of that vicious circle. How do we measure the level of bacterial enteritis? It's by scoring. We have always done scoring for coccidiosis. On this moment, we also score for bacterial enteritis. We look at the different signs like ballooning, abnormal contents, undigested feed particles, inflammation, and so on. But it's very important that you use monitoring to know your starting point and to also evaluate your solutions. Because with monitoring, you can measure the effect at the farm level, at the house level, at flock level, of the tools that you would like to use and you would like to judge. Not only performance should be used, because performance is too variable, it's too much depending on other things. You have to look directly into the effect of your additives that you're using on gut health itself. So if you want to talk about the tools, what we need to do is we need to break the vicious circle with solutions on all 4 steps of the vicious circles in the same time to have a good sustainable solution. Historically, that was done by these antibiotics. But when we look at its alternative approaches, we need to look at solutions that control the microbial ecosystem, but more and more we look into solutions that directly try to improve that gut barrier management and recovery of the intestine. The solutions to the vicious circle, if you understand the problem, you can fill in yourself all the solutions that are possible, okay? And you can see that all of the solutions that we have available, we can always put them somewhere in that vicious circle. Like AGPs, they were working on the second step of the vicious circle, the dysbiosis, but we also know that they have an influence on the immune system, okay? Anticoccidials, they work for the first part of the vicious circle because they control coccidiosis, but they also work antibacterial if they are ionophores, right? So they work on VC1 and VC2. For all of the products that you can imagine, you should be able to check where they fit into that vicious circle concept. And when you make a program, make sure that you don't have 10 products working on VC2 and you have none that is working on VC1, 3, and 4. Because then you will not have a solution for your vicious circle. Okay? And that is the most common mistake that I see people making. They over-focus on that VC2. Because, of course, they remember, antimicrobial growth promoters, it's in the name, right? They worked, and they were focusing on that microbiota management. So try to think more holistically, try to think what kind of alternatives to enhance gut health are working where, in what part of the vicious circle. All of them have a value, okay? Organic acids, probiotics, bacteriophages. Sometimes people ask me, which ones should I use? Which ones are the best? That's not the right question. We know with organic acids, we know the background, and I will not go in detail because the next speaker will talk a little bit more about that. But when we look at organic acids, we understand very well what they are doing now. We didn't know that 15 years ago. 15 years ago, we were mainly focusing on the antibacterial effects of acids. Today, we are much more intelligently understanding what organic acids in what form are doing what. We still have enough questions to be answered, but we have a much better understanding of the difference of the activity of organic acids in the feed or drinking water versus the activity inside the gut. I still see people making mistakes there. They sometimes think that the same acids that can be used as a feed preservative, they will have a very strong action in the gut. So we still have a lot of education to do, but basically we know more or less the difference between SCFAs, MCFAs, and so on. We know the effects on Clostridium perfringens, on gram-negatives, and so on. Okay? For probiotics, also here, I don't have an opinion which ones are better or not better. For me, the question should be, and then we have historic discussions, this bacterial species is a good probiotic and the other ones are less good. That's nonsense, of course. It's all to do with the mode of action of the probiotic. Whenever you consider probiotic, understand the mode of action. If it's an antimicrobial action, maybe it's producing a bacteriocin, then it's a VC2 product. If it is restoring tight junctions or supporting tight junction repair, it's a VC3 product, okay? Fair enough. All these probiotics have a mode of action, but that is not important what they are called, it's important what they do. And these are different mode of actions that you can fit in that VC concept. And that is what you should do. Outcome of probiotics, other speakers will talk about them. I put this slide in here because bacteriophages, I always was like putting them somewhere in the corner of my presentation because, yeah, they were very promising and they are very exciting and they are really cool when you look at these images, you know, like this very futuristic type of organisms. But I'm happy today that one of the speakers will talk about application of bacteriophages rather than dreaming. I hope he will satisfy my eagerness to learn about practical applications. But yes, indeed, we are really getting closer to phages becoming a realistic tool in our hands to deal with a couple of issues. We are with VetWorks, we are part of a European project there. We are not that far as the speaker that will talk today. But it's very promising, although we have a couple of challenges. The most important challenge with bacteriophages is resistance. But you also have other questions such as administration. Should we have continuous supply or more from time to time a supply? Do we have the right concentration of the phages and so on? So a lot of questions that I have that I hope I will see answered today in the presentation. Okay, whatever is the solution, remember, try to think where it fits in that vicious circle concept, and then you have to do as a producer 4 steps. First of all, you measure your impact by monitoring the birds. You score the birds. In the future, we hope to do that with biomarkers. On this moment, we work with monitoring the birds in order to understand the cost related with gut health issues. Secondly, we'll check all the tools we have, the ones that I listed. How much are we spending on them, and what do they give as a return? Third step, we make our analysis, and we try to think maybe we have too many solutions for VC2, but maybe we lack solutions VC1, VC3, and VC4. And once you have done that, then you can go not gambling what additive I should take from the shelf, but you can make a really sophisticated choice of additives that complete your program working on the 4 parts of the vicious circle at the same time, okay? So remember impact assessment, analysis of how we facilitate digestion today, and bringing together that veterinarian, production manager, and nutritionist to see where and what additives are missing, or maybe where we have too much attention for. And then you will be able to approach your suppliers and ask them, this is the product I'm looking for. I look for this kind of mode of action, okay? And with that, I think it's a nice introduction for the next speakers who will talk more applied on the solutions that they would like to introduce. Great. I would like to thank you.
Great introduction, Maarten. Thank you very much for that.
Okay.
And now we are... And now we are moving on to the most tricky part of every seminar. And that's the first question of today. Who has it? No hands. So it's up to me again.
Okay.
Maarten. Some producers step away from antibiotics pretty rigorously. under pressure of no antibiotics ever schemes and that. What would be the main issue they run into if they do that? If they just decide one day on the other, antibiotics have to go out, move out the feed?
So what you typically see in a situation where the transition is too abrupt and too quick is that feed conversion ratio is going up, typically 10 points, 15 points. We see on next to that, we would very rapidly see wet litter issues causing a lot of food pad burn and also a lot of breast blister and quality problems in the slaughterhouse. Okay, so that is what they typically would face if, of course, they don't have the knowledge of how to replace it. Now, I have to say, Fabian, it's not like it was 15 years ago. We saw these pictures where you are walking in the house and you have a boot on, it's a swamp, and I had it several times. I had a boot on, a little bit too big because I was the guest-like and they thought I was having very big feet. And I just have my boot behind me because it was like in a swamp. Okay? Yeah. This kind of images, we still see them from time to time, but they are becoming rare because, of course, wherever you have this trend of taking out antibiotics, people can use the experience that has been built in Europe. And there is a much better knowledge of nutritionists and veterinarians in terms of doing that. So I don't see the dramatic things anymore that I saw 15 years ago, fortunately.
Well, that's a good thing. And when it comes to welfare issues, some people say that using less and less antibiotics, that sometimes you are too late to intervene and get welfare problems from that. Do you see that as well?
Oh, absolutely. I even had yesterday here at the fair a discussion on this topic, where as a veterinarian, ethically, I oppose absolutely 100% by dramatic bans on antibiotic usage. Okay, it should be responsible use. We have an obligation as veterinarians to protect welfare. For the people who say, no, it's only the economics that count, and if the customer asks antibiotic-free, we should give it to them because they pay our bills. I will also give that point here. Having flocks not treated with 5, 6, 7%, 8% or 40% mortality, that is not customer friendly. It will, let's say, not do good to our business as well.
Exactly.
So we need to make sure that responsible use is implemented. By doing that, we will reduce antibiotic usage, but we should always keep that in the back of our pocket, the possibility to treat animals that are sick, okay? Yep. But not for subacute diseases or for gut health management on the long term. That should never be a long-term solution. And by the way, it would also not be your most economical approach.
No, all right. Well, thank you very much. There is the first question. Thank you very much.
Thank you very much. As you mentioned about the gut health, coccidiosis, and also he mentioned that farmers skip off from the anticoccidials and coccidios starts the feed. How about the vaccine? How can vaccine fit in this situation? Yeah. It could be, is it an alternative or something?
Yeah, you talk about cocci vaccines, I presume.
Yep.
Now, I use a lot of cocci vaccines in my programs. Now, there's one thing you have to remember. The cocci vaccines are live parasites, okay? So that means that if you have like a ranking of me as a vet, looking at my preferences, first of all, I would like to have good working anticoccidials. Because with good working anticoccidials, you can push your subclinical coccidiosis to as low as possible levels. When you introduce with a new chemical in a certain farm, you could have OPGs which are 0, okay? And you will see that in this situation, your performance, your gut health will always be superior to any of the other solutions. But that is more or less, for many farms, a theoretical context. Because for most of the anticoccidials, well, older anticoccidials, they are 30, 40 years on the market, and there's a lot of resistance and tolerance to these anticoccidials. And when we judge to switch from an anticoccidial in-feed approach to coccidiosis vaccination, it depends on our scoring. So when we see in our scoring that the levels are too high, we might decide to go to coccidiosis vaccination. But then it's very important to understand that you are creating a subclinical coccidiosis problem. That means that whatever I showed you on the slide with the damage of the coccidia, you are actually doing that. That means that you have to understand that this will have a consequence on the immune response and on the microbiota. So you have to support these animals when you use a cocci vaccine. Okay? So I hope that helps answering your question.
A holistic approach, that's for sure.
Fabian, you say it in my place. The holistic approach.
Yep. Should I? On top of that, another question raised to my mind.
You can also give the talk, in my place. No, go ahead, quickly.
Some farmer believes that vaccine can also be a predisposing factor for necrotic enteritis. How do you?
Yeah, absolutely. It is. That's exactly what I was saying before. It is. If you don't control the consequences of the live vaccination, and you have presence of your NE-causing strains in your farm, you will cause necrotic enteritis. That's what I'm saying, but there's very good ways to prevent it. The alternative, having high levels of coccidiosis, virulent strains, because you have a poor working antibacterial program, will also promote necrotic enteritis. Okay? But yes, you have to take care, you have to remember this is a live parasite that you're giving, so you have to flank it with organic acids, probiotics, whatever, phytogenics, whatever fits in your program, but you have to remember that when you vaccinate for coccidiosis, you have to give additional support to your birds to control that.
Thank you for your question. Thank you for your answers.
Thank you.
Your applause for Maarten. We want to continue our seminar with the second speaker of today, which is Antonia Tacconi, and she is a Global Product Manager, Gut Health for Pear Stop Animal Nutrition. Welcome to the stage.
Thank you very much.
Today she will focus on the effects of butyric and valeric acids on bird performance. And Antonia's presentation revolves around gut health and the role of short-chain fatty acids.
Correct.
The audience is yours.
Thank you very much.
Your clicker.
Thank you. I'm very excited to be here speaking in front of an audience, a real audience again, so I can see faces. I don't need just to look at the camera, so it's very nice to be here. Today I'm going to be talking about gut health and the role of short-chain fatty acids specifically. And just to give you a short overview about what you're going to hear, it's about short-chain fatty acids, production of those acids, types of acids that are out there, the transport mechanism of these acids into the epithelial cells, and their role in gut health. Then we're going to focus a little bit on butyric acid, exploring a novel concept, which is the one of valeric acid, and talking about combination of acids in general. So when I talk about single-chain fatty acids, or also branch-chain fatty acids, I'm talking mainly about acids produced in the gut by the microbiota. They're produced out of non-digestible carbohydrates, mainly polysaccharides, plant cell walls, but also resistant starch, soluble oligosaccharides, endogenous products in general. There is also an alternative route for production of single-chain fatty acids, which is the fermentation of amino acids and protein also in the intestine there by the microbiota. And this is specifically related to the branch-chain fatty acids, which are a bit more complex. They are not just sort of nice chain, but they have a bit more of spikes in there, as you can see here with the isovaleric acid. When I talk about single-chain fatty acid, I specifically talk about acids with a length of up to 5 carbon atoms. So we're talking about formic, acetic, propionic, butyric, which are the most known ones, right? But also we're talking about valeric, isobutyric acid, isovaleric acid, and 2-methylbutyric acid. So they are also very important. And all of these are produced by the gut microbiota in general. But we know, as animal production is today, that the gut microbiota, sometimes, as already Martin said, can be sort of affected. There is a dysbiosis, so some of these acids might not be produced, but they are needed by the animal. And why are they needed? Because they play a very important role in the epithelial cells of the animals. And to get there, there is a bit of a misunderstanding, I think, sometimes, so that's why I'm talking about this, is that they need to actively be transported from the outside of the epithelial cells inside. So, and it's not a diffusion, because these acids have pKa values that are around, like, lower than 4.8, and we know that the pH value in the lumen is higher, so they are dissociated. They cannot bypass the membrane as such, so actively they are transported. And up to now, there are 3 transport mechanisms that are known, which are the single-chain fatty acid bicarbonate co-transport the monocarboxylate transporter, and then there is the sodium-dependent monocarboxylate transporter. For you to understand, these are proteins embedded in the membranes, and our acids act as ligand, so they will attach to these proteins and then will be transported inside where they can exert the mode of action. And when we talk about the mode of action of these single-chain fatty acids, so we're talking about how they play a role on gut health, there is mainly 6 ways on how they can act. And these ways are very well known, very well studied, specifically in humans. We still don't know that much of these results in animal, but there are more and more publications looking at specific these mode of actions nowadays. And first of all, there is the epithelial function, right? We all know that single-chain fatty acids are energy for epithelial, so they're taken up. They're very important for them. They are important for electrolyte transport and so on. But then there is also the effect that they have on the stimulation of mucus production and the quality of this mucus. So very important, this is the layer that is right outside the intestinal wall, right? We need to make sure that this protects the wall from toxins, chemicals in general, bacteria, so it's important that the quality of this layer is good. They also have a direct effect on intestinal barrier function, so what we usually talk about like gut integrity. So they have an effect on gut integrity, supporting like villi length, crypt depth, the ratio between the two of them, but also they have been shown to have an effect on the expression of genes that are involved in the production of tight junction proteins, so the occludins and claudins that we all know very well. Single-chain fatty acid also have shown to have an effect on the production of the mammalian's antibacterial peptides, so the so-called defensins. I don't know if you heard about them. It has been shown that they actually can affect and increase the production of these antibacterial peptides that help against bacteria, viruses, and other problems, I would say. Single-chain fatty acid, specifically also butyric acid, has been shown to have effect on the immunoregulation. So we have effects there on dendritic cells. So I would say that there is an increased production of dendritic cells. These dendritic cells are very important for immune responses in the animal, and we see these with single-chain fatty acids. And then, this is a bit less studied, but there are also some effects seen on the enteric nervous system, so the motility of the gut and these effects. So we see that in general, single-chain fatty acids have an impact on gut health, and as Martin already said, it's not just about the antimicrobial effects they have. It's much, much more behind it. We still don't know enough, but we're looking more and more into it, so there are more and more publications coming out in this direction. When we talk about single-chain fatty acids in animal nutrition, we all know about formic acid used, right? That's what Martin was saying. This is an acid that is usually used for the reduction of the pH, so upper part of the gastrointestinal tract, very well. Not so much known for its effect in the lower part of the gastrointestinal tract, but then there is also propionic and acetic acid. We all know that very well. But I still think that butyric acid is the most studied one in animal nutrition. And there are different types of butyric acid that can be used. So coated butyric acid, Martin already had it on one of his slides, I think. Butyric acid salts, and then esterified versions of butyric acid. And we could stay here and discuss which is the best one for a long time. That's not the scope of today. But what I wanted to show you is that there are a lot of studies showing performance of this butyric acid, but there is more and more coming also showing effect on gut health. And so here, I don't know if you can read it. This was just to show you that there is a lot where they are looking on gene expression, stimulation of cytokines production, stimulation of gut integrity, and so on. So there is more and more coming, and I think we will see more in the next years. And then there are those other acids that are not that well known, but we all know that they are there. So I'm talking about isovaleric, valeric, 2-methylbutyric acid, and so on. And the valeric acid itself has been becoming more and more important in humans, and now also in animals. Most of the information that we know about valeric acid comes either from in vitro studies, mice studies, and a lot of it comes out of epidemiological observation in humans. So I mean, when you have a group of people that has a specific disease, you look into their gut and check what is the level of single-chain fatty acids in their gut, and can this be linked to the disease itself? And by doing this, we've seen that there are a lot of effects of valeric acid. So we've seen that with valeric acid, you can have a fast recovery when people of body weight when people are actually injured directly in the gut. There is prevention of inflammation that plays an important role, maintenance of gut integrity, stabilization of the gut microbiota. And then it has been seen that low levels of valeric acid are linked in humans with diseases. Like, for example, there are studies on children with eczema. All of them have very low levels of valeric acid. People with cancer have low levels of valeric acid in their gut. So we're getting more and more information on this, and I think the most known mode of action is the inhibition of the HDAC receptors, which are very much linked to cancer and colitis in humans. So we talked a lot about humans, but what can valeric acid do in animals, right? So we looked at valeric acid in the gut health of broilers, and what we can see here is that it has an effect, and actually a significant effect, on increasing villi length. Just a numerical effect on decreasing crypt depth, but then also a significant effect on the villi to crypt ratio. So what we talk about gut integrity, we've seen that, that there is an effect on that. We've also seen that if you look at the density of the GLP-2 immunoresponsive cells, they are higher. And these cells are actually important for the turnover of epithelial cells, meaning that if you have a good turnover of these epithelial cells, your gut is healthier. So that's also an indication for valeric acid playing an important role there. On top of it, if we look at valeric acid, we've seen that in broiler directly, it can help protecting against necrotic enteritis. We've heard about it, what it is. I just want to show you one of the studies we did here with monovalerins. So it's an esterified version of valeric acid where you have a glycerol with just one branch of valeric acid on it. And in this trial, this was done on COB 500. We have a negative control, a positive control, and then we had a bacitracin group and our valerin group. And as you can see, if you compare, so the study was positive, because you can see the positive group had very bad performance. And if you compare the group of bacitracin with the monovalerins, you can see that there is no statistical difference in terms of feed conversion ratio, average daily weight gain, and lesion scores. There is still a better results with the bacitracin on a percentage of mortality with necrotic enteritis, but we are still doing better than just the positive control with valeric acid. So it might be an option to be used in this direction. Also, other results here where I wanted to show you that it's not just about, oh, one molecule will work for everything. It's also about the dosage. That's very, very important. So you can see here are two trials. The first one was done with very high levels of valeric acid. And if you look at the results, you can see that we have a significant results on reducing lesion scores in animals. But then if you look at the performance, that's not so good, meaning that high levels of valeric acid help you with the gut itself, but not on the performance, and that's something we should, however, be looking at, right? Not just gut health is important, but we want our animals to perform good. And then if you look at the second trial, that's where we looked at a bit of lower dosages of valeric acid, and you can see that there is results both in body weight and also in reducing percentage of necrotic enteritis lesion and lesion scores in total. When we talk about organic acids, we all know that we can have combinations of them, and it's clear that more than one acid is always better than just one. That's not something that I came up with, it's something that has been studied. This is a meta-analysis done by a group in Brazil where they look at 121 publications related to organic acid and broilers. So they analyzed in total of around 51,000 broilers fed with organic acids. And you can see that in general, performance is always better with the blend of acids. So 2 is always better than 1, and more than 2 is also better than that. That's why we started thinking about those acids that play a very important role in gut health. And we've heard about butyric acid, we've heard about valeric acid, and so we looked at the combination of the two. And as you can see here, we have a trial where we had a control group, a group with just tributyrins. So this is butyric acid, esterified butyric acid, where we have 1 glycerol and 3 butyric acid attached to it. And then a combination of the esterified butyric acid and the esterified valeric acid. And you can see that we have, for both groups, so we know butyrins are good. So we have an improvement compared to control with butyrins alone. But we also have a huge result when we combine both of them, a result that is better than just using one, which is actually underlining even further the effect of 2 acids better than one. Here you can see that the combination of the 2 acids compared to control improved by 5 points feed conversion ratio, and just when compared to just butyric acid, it was additional 2 points of feed conversion ratio. We've done tests with this combination on more than just one trial. Here it's the trials we can show are 8 trials, most of them done in Europe, but we also have 1 Chinese trial done in 2021. And you can see that out of the 8 trials, actually 6 has statistically significant better FCR, and the average of FCR improvement was 4 points with the combination of the 2 acids, and consistency of results was also shown in body weight, where we have, in average, an improvement of 3% in total. So from my side, I just want to, as a summary or take-home message, as we would say, I would like to tell you that single-chain fatty acids are important. We're learning more and more about this. It's not just about reducing pH in the feed or preservation effect, but it's also about gut health. And we've seen that they play a very important role for epithelial function, mucus production, barrier function, immune regulation, and so on. Butyric acid being one of the most studied one, it has been proven to have effect on performance, and there are more and more studies coming also with its effect on gut health as such. And although valeric acid is a quite new concept, it's actually a very, very promising concept for animal nutrition, and we are looking further into that. And the combination of 2 is a promising tool for animal production and broiler production as such. Thank you very much.
Thank you, Antonia. Thank you, Antonia.
Thank you very much.
Really good. I'm looking for hands for the next question. No? It must be a really clear presentation.
Yeah, it was perfect, right?
But of course.
I can go home happy. Oh, there is one.
Really good.
For tributylin to work, you require lipase enzyme to break the bond between glycerol and 3 molecules of butyric acid. So in young chicks or where the high fat diet is there, how lipase will be available to break this bond?
So you mean where the tributylins will actually be effective in?
Yeah.
It needs to be in the intestine where actually you have the lipases that can start working on like breaking down the glycerol structure so that then you can have the butyric acid that is free and available for the animal.
But in young chicks, lipase secretion is always on lower side.
Yes.
And when the fat is more, this lipase will be used for fat digestion, not to break this bond. So how the efficacy of tributylin will be there?
So if I get your question correct, if I might repeat it because I'm not sure, is that you're saying in young chick it's difficult to have lipases working on the tributylins. Okay. Well, we've seen that we still don't know exactly what the ratio is between like how the lipases are working, but what we've seen is that especially in young chicks, so it's grower and starter and growers, that the effect of butyrins is very, very high. So they are actually released there. The butyric acid is released there as effect there. I cannot tell you exactly how the lipases, the ratio of the work of the lipases on those components. That has never been studied before in my knowledge.
Well, thank you for answering. Another question from the audience? I had one prepared. Where does especially the valeric acid fit in the vicious circle which Maarten described? Can you explain that?
Yeah, I think it's not that easy to answer because there is like the effect on antibacterial, and we've seen that the valeric acid had some effect on producing bacterial, and peptides, antibacterial peptides. So it could be an effect on that one, but it also has an effect on the immune system. And we know that a lot of energy that is usually used for overcoming these issues with subclinical information doesn't go into the growth of the animal. So it might be also like, yeah, 3, I would say. I had, Martin is showing 2 and 3, but yeah, that's what I'm saying. Like it should be 3 also, yeah.
Yeah. And does it help then to put together the butyric acid and the valeric acid?
Yeah, so what we've seen is that it's still unclear how the ratio of these acids should be in the animals, and I think it very much depends on the condition in the farm themselves, because it's difficult to really put a number on gut health itself, but the combination we've seen always works better than just the one alone.
Yeah. And you talked about the 2 combining, but would you think of combining more short-chain fatty acids?
Actually, we're looking at that, and not only short-chain fatty acid, but also we are trying to add some phytochemicals for boosting further the immune system of the animal. So one of our products actually is a combination of butyric valeric acid, and we have some carvacrol in there. So yeah, there is a lot that can be done also to tackle then these other V's that Martin talked about.
Oh, interesting. We will tackle them all, Martin, no worries.
Yeah, Martin, I'm gonna bring you the solution for all.
All right, Antonia, thank you for
very
answering.
much.
Your applause for Antonia. Then it's my pleasure to introduce the third speaker of this seminar, and that is Professor Jaroslav Dastic. He is CEO, President, and President of Board of Directors at Proton Pharmaceuticals. And Professor Dastic will get us up to speed about Bacteriophage, actually a century-old technology which has been pushed to the background when antibiotics were invented. But as far as I'm concerned, it's making a real strong comeback. So, Professor?
Thank you. Thank you.
You were in my blind spot. I'm looking forward to hear how bacteriophages can reduce the use of antibiotics.
Will do my best. I hope I will satisfy your curiosity in this regard.
Thank you.
Good afternoon. So let me say that bacteriophages were already kindly introduced by Martin and Fabian. So I will repeat the introduction and try to make some comments that are based on our practical experience from developing bacteriophage-based product for animal health. So Proton Pharmaceuticals is a technological platform company. When you think of bacteriophages, you can think of crop protection, food preservation, human medicine, veterinary medicine, and nutrition and feed additives are, I will make a point, are also a good candidates for using this bioactivity. So that's statement of our mission. I think that actually using bacteriophages that are, to make sure, are natural component of microbiome, very important. That's dominant component of the viral part of microbiome are bacteriophages, is actually fitting very well into this trying to solve the complexity of bridging between the economic performance, sustainability, animal welfare, trying to reduce antibiotics to mitigate AMR crisis. So let me spend a few minutes describing this solution. So Proton Pharmaceuticals is a Polish biotechnological company that has the R&D and the headquarters component in Łódź, Poland, But we have also a daughter company in India. We enter with the first bacteriophage product that has already registration and the market access on 3 continents. And we are in a very advanced, still very painful, but very promising process of registering our first bacteriophage product in European Union. So I will, as I said, introduce you to bacteriophages. It will be a really crashing course, just a few minutes. And bacteriophages were discovered early in 20th century. It's not alternative medicine or a magic. They've been discovered in Pasteur Institute and in London independently. And they were used on quite massive scale as in human clinic, as a therapy for bacterial diseases. What we know now is that bacteriophages are natural controller of bacteria on the planet. From 15 to 30% of existing bacterial population are killed every day by bacteriophages. So they are powerful killers. And they somehow keep the balance in our environment. And because there is plenty of bacterial species, and bacteriophages are quite species-specific, very focused on particular type of bacteria, so you have abundance of bacteriophages on Earth. There are some, of course, hard to prove numbers like 10 to 31 of bacteriophage particles, generally expected. What is important for the practical use in animal health, bacteriophages are composed of protein and nucleic acid. So obviously, they are residue-less solution. They are not leaving anything in tissues. They don't stay in like a stable form if there is no host somewhere in the environment. This is quite important. And of course, because as I said already, they are important part of the microbiome. They are sort of important elements of the microbiome-related immunity or resistance to different pathogens. And I already stated that they are very specific. So let's go a little bit more deeply into bacteriophages. Bacteriophages you can split into 2 types of cycle of life cycle. They are either lytic or lysogenic. If they are lytic, their strategy is to propagate, to infect bacteria, to propagate, to kill bacteria, release, and look for another bacteria. If they are lysogenic, their strategy is to infect bacteria, integrate into bacterial genome, stay quiet till there is a crisis, then activate and release progeny and look for another host. Those are very different strategies, and for our purposes, at this moment, the attractive are lytic phages. And to make sure that phages are lytic or lysogenic, you have to analyze their genome. So the basic analysis of bacteriophages and the usefulness for practical application is based on genomics and bioinformatics. We are supporting our bioinformatics by artificial intelligence. You can find open access in Phage AI when if you provide the sequence of genomic sequence of bacteriophage, you will get very quickly the sort of a likelihood if the phage is lytic or lysogenic. And we are selecting only lytic phages. So this is the lytic cycles. And part of our work in developing product is screening environmental samples for naturally occurring bacteriophages, analyzing, selecting the lytic, and then composing the cocktail where each of the bacteriophage of the component play or support the overall efficacy and activity of the cocktail. It's not trivial, it's not just extending the host range, the coverage, but it's also mitigate the risk of resistance. Answering Martin's concern of resistance of bacteria to bacteriophages, you can achieve at least 10 to the 4th decrease in the number of resistant mutants by properly, rationally designing the cocktail. So, okay, so that's about the science behind the technological development. That is basically daily routine of our R&D team. At this moment, is 40+ scientists and technicians working with the tools that define this technological platform that we spent several years developing. And that also contains the components that are very important for sort of commercialization and practical application, such as looking for a standard for bacteriophages. One of the problems we are facing is that bacteriophage product will enter in one or another registration pathway. So we are talking about the quality standard, good laboratory practice. We've got the first to simply count the number of active bacteriophages, and other elements of sort of validation and standardization that are needed if you want to scale up and use some bioactivity on industrial scale. And we really believe that bacteriophages are perfectly fitted to make a great impact in mitigating the AMR crisis. And I know we will focus on animal health and poultry, but just let me say that in terms of microbial resistance, bacteriophages are sort of being perceived and used in two different ways. So we are focusing now to remove as much as possible of antibiotics from the food chain and from environment and mitigate the AMR by providing the industrial scale solution to achieve this goal. Other companies are developing bacteriophage for human medicine frequently as a sort of last resort, meaning, okay, you have like highly antibiotic resistant bacteria and there is no more antibiotics, so you are treating a patient with bacteriophages. So we strongly believe that bacteriophages are much better suited for prophylactic large-scale use for different reasons. But of course, both ways are worth to pursue. And talking about antibiotic resistance and the AMR crisis is not like blaming animal industry, but it's a matter of fact that the usage of antimicrobials in terms of massive usage is somehow in a significant part related to the non-human medical usage of antibiotic. And it's well acknowledged, it's been introduced by Fabian, there is a goal to improve the situation by reducing antibiotics. Of course, we need to keep the sustainability, the performance, we need to maintain the economics of the industry. And while looking for AMR mitigation, we are definitely on this side and we are looking very closely during the development of our product on the side of the sort of a commercial viability of such solutions. So why phages are good in mitigation of AMR? Because besides simply reducing the antibiotic use, they are also killing antibiotic resistance bacteria. So just adding them when you think of usage of antibiotic is sort of having the impact of like number of antibiotic resistance bacteria in manure or similar sources of antibiotic resistance genes, because this is antibiotic resistance is caused by antibiotic residue in tissues, in soil, but also by the propagation of antibiotic resistance supporting genes among bacteria. So this is not just the bacteria in the animal, the environment is also affected. So it's really good to have the means to remove or reduce the number of emission of antibiotic resistance bacteria. And bacteriophages is not like a simple replacement of antibiotics. No, like we are throwing away antibiotics and start using bacteriophages instead. It's, in a sense, it's coming to the beginning because one of the first clinical trial of antibiotics in London was run in parallel with the trial of usage of bacteriophage therapy together with newly discovered antibiotics. And there is such a phenomenon called phage antibiotic synergy. Some people focus on that. The combination is quite interesting. But of course, from the massive scale of use of antibiotics that we have to reduce, more important is when we can simply replace the antibiotic, especially for prophylactic or for modulation of microbiome, for modulation of microbiome to gain performance by different ways, including everything that is presented here in this seminar. And our first commercial products are for poultry. So the one is called Bafazole, and is targeting Salmonella. It's really very powerful against Enteritidis and Typhimurium, but also protect animals from different serotypes with different efficacy. The second product is targeting avian pathogenic E. coli. I'm using a general term without specific serotypes. That's a longer discussion. And those two are already in commercial use. Both are feed additives given to the water, to the drinking water, from the first day, as they don't have any side effect and can be used prophylactically, and they prevent the colonization of microbiome by these two Enterobacteriaceae family bacteria that are not necessarily needed, although they're frequently present in birds. So Bafazole consists of 4 strains of phages, well documented. It's a well-characterized product, and it has already a certain history of use. So I will present you the data more from like practical farm field trial, then from a challenge type of experiment when you are adding Salmonella to birds and challenge the birds with Salmonella and look at the reduction of Salmonella count, because we've done many of such experiments. So this is more like the data that they just want to signal. So this is a real life, not a large scale. They were 10,000 chickens, and simply we were looking together with future customer if prophylactic usage of our product will mitigate the problem of Salmonella. And the problem of Salmonella, the sort of the detection point that we established was at the slaughterhouse. So it's very practical, not very academic, difficult to control. But the convincing result that basically you had better performance, slightly better, but better performance by using the product. And definitely you didn't have a single report of salmonella claim at the slaughterhouse. So that was the outcome. And of course, from that point of view, Bafazole can be perceived as a food safety tool. And it's how we present it. But despite the fact that there is a strong belief that Salmonella, other than Gallidarum, doesn't do much harm to birds, that depends on the particular strain. But this making Salmonella is making negative impact on performance. And we observe already on the larger scale than presented here, this positive effect on performance in a real-life scenario. Because Salmonella is quite prevalent in the environment, it's very hard to control. So here was a 20,000 chicken involves total. Now we are running similar field trial that we observe on millions of broilers. And so far we see we can confirm the results over and over. Now the second product is targeting avian pathogenic E. coli and called Bafacol. It has 5 strains of Bacteriophages. It's also given in the water, drinking water. And the effect, sorry for the title, there is a wrong title of the slide, is not commercial farm trial, is a testing center challenge model. So the avian pathogenic E. coli, the 2 strains were mixed, given to the drinking water. So as you may see here, the comparison, there are many groups. So here maybe I will guide you through this. So there is no treatment, T1. Then there are T2, no treatment and no infection. Then there is infection, T2, challenge with E. coli. And T3 and T4 are 2 different regimes of Bafacol. I'm running time? Over? OK. So make it quick. So as you see, there was a reduction of mortality. And there was improvement of body weight performance. And we compared this to this sort of a standard use of antibiotics that was typically introduced by the farmers in the place where we were testing. OK, and that's the last slide, I know. OK, so we have the 2 commercial products for poultry. There is additional in the pipeline. We have also product for aquaculture and for anti-mastitis. Maybe this. And we are looking for different kind of collaboration if you are interested in bacteriophages. Thank you very much.
Well, thank you. Thank you, Professor Dastis. Thank you very much. Quick look at the audience for a question. I have one. You mentioned that it's currently registered as a feed additive. Mm-hmm. Is there a future as it for medicine purposes as well as antibiotics?
You mean if the different registration pathway?
Yeah, because the registration is pretty different.
Definitely, huh? But when you think of the gut health, you can think right away about few bacterial species that are sort of having negative impact of microbiome and should be prophylactically taken care of. Exactly. So we are focusing on that. But of course, intervention with bacteriophages, sort of medical intervention is possible.
Yeah, because that's what happens in human health as well, eh?
Pardon me?
That's what's happening in human health as well.
Yeah. So, but in human, there are also people who think more like a diet supplement than drug. So it's still open, in making, in progress.
All right.
Sorry.
Well, great future for that. Well, thank you very much. Oh, one question here, Martin.
I just have one burning question. It's very innovative. Thank you for the great presentation. I'm just wondering, from a cost of production point of view, is this like comparable to antibiotics? Is it like more expensive, less expensive? Can you, without revealing your deepest secrets, but can you?
Yeah, I can
answer.
I can answer right away. Right now, we are engaged with the large broiler producers, and we are sort of looking from both sides in economics. So the idea is to not use antibiotics, call it metaphylactically, prophylactically, on the part of the production as large size, and use our product. And we are, after 2 cycles, so far, considering the performance and the cost, with our price, we were able to go slightly below the sort of current cost basis. So it means we move into antibiotic-free, not increasing cost in this particular producers, in this particular location. So we are sort of working on that.
All right, well, thank you. Is it a good answer? Maybe you can look each other up. A big hand of applause for Professor Dastic. That brings us to the 4th and last speaker of today. I want to welcome Laura Hoving, and she's Technical Service Manager Poultry in the EMEA region for Christian Hanson. Welcome.
Thank you very much.
I will hand you the clicker already.
Yes.
Her talk of today, in her talk of today, she will tackle one of the issues which is on the mind of many, which is raw materials. And her presentation title is "Don't Let Raw Material Ruin Your Profitability." So, Laura, how can we ensure that our birds do well? Please explain.
Yes, well, I will gladly explain to you. Thank you very much for having me.
Thank you.
It's very nice to see, as other speakers also said, see real faces again instead of a screen. So my name is Laura Hoving. I work as a technical service manager for Christian Hanson. And feel free to reach out to me on LinkedIn if you want to know more about me. So how can we prevent raw materials to ruin the profitability? So right now, there is a big challenge in the market if you look at profitability. Feed prices are increasing tremendously. They have been increasing over the last year due to COVID, due to the war. So availability is challenging at the moment. Quality is also a little bit on the challenging side. So that's a big challenge for the industry at the moment. But there's also a big opportunity in the market. So if we look at consumer trends, consumers really look for healthy and safe foods. They value animal welfare very much, but they also want to eat foods that limit the climate impact. So there's a big opportunity in sustainability as well for the animal production side. So the big question here today I'd like to answer for you is how can we go from a dilemma of having to choose between the challenge and the opportunity to go to a situation where you don't have to choose, but you can have both. So first I'd like to introduce Christian Hanson to you very briefly. So we're the worldwide microbial leader, which means we have a data bank of 40,000 microbial strains. Every second cheese or yogurt in the whole world will have our bacterial cultures in it. So in human products, we're very, very large. We have over 300 academic partnerships, and corporate nights actually ranked us as the world sustainability leader. So it's something we're very proud of. And we're basically using the power of good bacteria to improve life in general. So this one, well, you're probably all familiar with these graphs. This is just the actual day-to-day challenge we're working with the increasing raw material prices we see all over the world. And if we look, on the other hand, to the long-term opportunities, research has been done recently for consumers, and they answered that 78% of consumers are really looking for more sustainable food. So they are looking for a shorter production chain. They want foods that are locally produced, raw materials that are locally produced. And also 77% are looking for new and healthier ways to live. So that's something we can really have an impact on as a poultry business in general. So big opportunity there for us. So now is the big question: how can we go from, do I choose profitability in the short term with the high raw material prices, or do we go into the consumer trends and follow sustainability and health? What do we choose? How do we do it? So with using probiotics, we can offer you the possibility to not having to choose. So you can have the short-term profitability, and you can have the long-term sustainability and consumer health demands. So if we look to production profitability, very important. So if you would use probiotics, more meat or eggs will be produced. It's all scientifically backed up. So we've done a lot of research to for the results we have. So the feed usage will be improved. There is less waste at the slaughterhouse, so that's very good for less food waste in general. And also less drugs used, so less antibiotics being used. There's also a big impact on animal welfare and the environment. So the flocks are healthier, which means you can have reduced heat stress, there's less foot path lesions, and there is a reduction in greenhouse gas emissions as well. And if you look to the healthy foods side, probiotics give you the opportunity to have a cleaner label. They reduce salmonellas, and there's also a reduced need for antibiotics. And if we go a little bit further into one of our newest triple strain products called GalaProfit, there's a few parameters I'd like to share with you that really grasp the numbers that talk to everybody, I think. So if we look at the health and feed safety part, so using GalaProfit will reduce salmonella shedding with 1 log, and for the non-mathematical people, that means a reduction of 90% of salmonella shedding in your flocks. If we look at an economical profitability part, there is an overall improvement of 3 points of FCR, which is backed up with over 25 field trials in Europe. And if we go back to the health part again, in antibiotics use, there is a reduction of 26% of antibiotics use overall in all of those flocks. And also, if we go to the slaughterhouse, so the food waste part, there's 26% less waste at the slaughterhouse, less condemnations. And I would like to make the 3 points of FCR speak to you a little bit more even. So last year, 3 points of FCR would mean 3 cents per bird, or roughly 10 euros of a decreased cost in your feed per ton. Whereas at the moment, with the high feed prices, 3 points of FCR will bring you 4.5 cents per bird, or will reduce your feed cost with 15 euros per ton. So instead of having to increase your feed price all the time, by actually implementing a product like GalaProfit, you can reduce your feed cost with 15 euros per ton of compound feed. So the big question is, how can we secure bird health and profitability with probiotics? So I just explained a little bit about GalaProfit. I don't know if everybody can read it, but you'll get the article with the graph in it as well. So at the moment, what we see if we focus especially on feed safety and gut health, which is one of the modes of action of our probiotics. So if there's a shortage in feed ingredients, there's basically 3 things you can do. You can choose to increase your crude protein levels in the diet, which is one option. The second one is to decrease your total nutritional density in your diet. So that's more a profitability one. And the third one is you can adjust the safety margin for alternative feedstuffs. So with some raw materials becoming more difficult to get, and especially with grains like wheat, and there is expected to be a big shortage later on, so other raw materials will be used more frequently. You can adjust your safety margin to do so and put them in your feed. The overall conclusion, whichever one you choose, if you don't use a probiotic in your feed, if you look at the crude protein one, you will maintain your production levels, but there are more risks for dysbiosis and gut microbiota problems, so footpath lesions and things like that. If you use probiotics, in all 3 of the cases, you will maintain your production levels, but you will also maintain your gut health, which is very important because healthier birds mean healthier meat, mean more profitability for the farmer and also for all the others in the industry. So, and in general, we already showed it looks at a 3-point decrease in FCR. So that was a very short presentation from my side. The take-home messages I have for you is that the poultry industry really needs to stay profitable on the short term with all the increases in feed prices and raw materials we see. But we also have to really look at the long-term opportunity to keep up with the key consumer trends and invest in sustainability and more healthy feed, shorter supplies and CO2 emissions. And well, the most important one is if you use Chr. Hanson probiotics, the poultry producers can stay profitable and competitive in the long term by filling well-established consumer trends. So.
Thank you very much, Laura, for explaining probiotics and the profitability aspects of it, and health aspects, of course. I was really surprised about the immense increase in prices of feed the last couple of months, and also that it has such a big impact because you said like 15 euros a ton. And is your expectation? Will it be even more damaging to the producer, the feed cost increase?
I expect feed prices will increase, raw material prices will keep on increasing even more. So it's very, very, well, interesting what's going to happen with the new harvests, because we're sort of, well, finishing all the old grains and going into the new harvests. But another very, very important part is, I mean, you have the increase of the raw material and the feed cost for poultry in general at the moment. But if the retailers don't pay for the product, it's going to be very, very difficult. Yeah,
the margins will be even tighter.
Margins will be even tighter. So yeah, we're really looking at the retailers to compensate the higher raw material costs, but also the higher energy costs as well. So it's very interesting what's going to happen.
Interesting situation. Is there a question from you, the audience, at this moment in time? Maarten?
Yeah, thanks for your nice presentation. If you would have to position your the mode of actions of your strains within your probiotics, where would you position them in the VC concept?
Well, we have a triple strain product, so all our different bacteria are selected on specific modes of action. So every bacillus has different modes of action. So actually, if we position them in your circle, they tackle all 4 of them. but each and every one does it in a different way. So one maybe do 1 and 2, and the other one just 3 and 4. So it depends on which species. But it all, strains matter, so that's all the...
Really interesting. So you have to come up with a new vicious circle, Maarten, because it's solved.
Or just...
Really good. You also... You also mentioned that profitability in health can be secured by this probiotic, right? Are there any other gut health additives which could do the same?
Well, yeah, thank you for your question. It all comes down to the modes of action of those products. So I don't know them because I work for Christian Hanson, so I only know the modes of action of our probiotics and of our bacteria. Mm-hmm. But looking at the types of modes of action the bacteria have, they tackle, well, in Maarten's vicious circle, they tackle basically all the stages. So it might be hard to find a product that tackles all 4 of them at the same time, like probiotics can do.
Well, it's a good take-home message as well.
Question.
There is a question, yeah?
Yeah.
I didn't see it, sorry.
You mentioned the price increases of wheat. Mm-hmm. If you would change the grain source in your feed, would that have an effect on the type of probiotic you have to choose?
No, it wouldn't. No, it wouldn't have to change the type of probiotic you choose. If you look at our product with the triple strains, they have modes of action that increase the safety margin, really. So if you're using a little bit more, dangerous is not maybe the right word, but feed ingredients, because of the lack of availability of the normal cereals you would use, like wheat, probiotics will increase your safety margin. So they pretty much decrease the risk of dysbacteriosis and problems in your gut microbiota, because they keep them level and, well, they have several modes of action that protect it.
Well, clear answer. Last question from my side. Yep. We talked a lot about prices and profitability, but sustainability is an item as well for our industry, of course. Could you measure the impact of this probiotic on climate?
Yes, we actually can. We have a special calculator for that.
All right.
And I can give you an example, so maybe to speak to everybody a little bit more. If you have a poultry feed production company and you produce feed for, say, 35 million birds per year, so the amount of carbon dioxide we can say, or you can save by using Galiprofit in all of that feed, it comes down to, well, look at a forest of 50,000 trees. Those 50,000 trees will take up carbon dioxide and make it oxygen again. The savings you will make by using Galiprofit is the same as a forest of 50,000 trees. For 10 years, all the carbon dioxide they take in, you will save that much.
That's pretty impressive, isn't it?
Yes,
yeah.
Yes it is.
And a good example to show to the world as well.
Yeah.
Last round through the audience for questions? No? So a big round of applause for Lara Hoving. Thank you very much.
Thank you.
Well, that brings us to the closing part of this seminar. Today we heard about the importance of gut health in broiler production, and we were handed some great tools to keep our birds healthy, even in the most challenging conditions. I want to thank all of today's speakers. They are still all here, right? Maarten de Gussem, Antonia Tanconi, Jaroslav Dastis, and Lara Hoving. A big round of applause for you guys. Thank you for being here as an audience as well. Really enjoyed a couple of questions. It was my pleasure to have you here as a guest of Poultry World. And for now, I would say, have a fruitful VIV and start walking again. Thank you very much, and see you next time.